the reserve. For synthetic, we go straight to examples. I understand how I teach. I don't use the book, so the examples may not be exactly the same as what we are doing. The numbers keeps going. So 1, use synthetic division to find the remainder and quotient of A x3 plus 2x minus 1. Just put something that is similar to that thing. It's not exact when divided by x minus 1. I think I've missed it. Okay, so here we are saying the first thing you do is you get the divisor x minus 1 equated to 0 and obtain x is equal to 1. This number you get here is what you take in this structure and collect the coefficients of the polynomial starting with the highest degree. So for x3 we have 1. For x squared is not appearing here, meaning that we must improvise and bring its coefficient, which is 0. That's the reason why it's not appearing there. And then for x is 2, for the constant, -1. And then drop this 1, you drop it down, then you multiply this 1 by this 1. What we'll get is a 1, and then we add it to 0 to get a 1. Again, multiply by the 1 from outside, we get a 1. We add, we'll have 3. Multiply, we get 3. We add, we'll have 2. What you are saying is that this last number here is our remainder. So the remainder is equal to 2. And the quotient is formed by these coefficients here. You must just be careful. If your polynomial is to the degree 3, the coefficients will start from degree 2. So we'll have the first one, 1 x power 2 plus the second one x plus 3. I was saying you can write x3 plus 2x minus 1 as a product and sum of the divisor multiplied by the quotient, and then you add the remainder. Okay, so I think I've changed the question a bit. It was supposed to be a plus there, so I had to get a 4, but still the same concept. This means that you can write your polynomial in the form divisor multiplied by the quotient plus the remainder. You can also write it as the quotient plus the remainder over the divisor. You can also be asked to write it in that form, but nothing changes. Do we have a question on this one? Okay, the thing is that we'll keep coming back to this synthetic throughout the whole polynomial function. So what we'll do is we'll go to the part which is a full packaged question of this. So here I've just given A is okay, and then I'll change the question to 2. So this, suppose this was 1, so just add A, it's all right. 2, sketch the polynomial. functions. A, f of x, then for a polynomial, we normally use p of x, but it doesn't matter. P of x is equal to x power 3 plus 2x squared minus 1. Okay, so sketch this polynomial. Whenever you're asked to sketch a polynomial, you've been asked to do so many things in one question. The word sketch means a lot here. The first thing we do is to have this thing factorized. So our step one is to factorize px. Okay, how do you factorize it? Factorize, look for a factor to look for a factor, you use guesswork. What I mean guesswork, trial and error method. Use the trial method. But there's a way that you try. So you get the coefficients. So you use the factors, use the factors of the coefficient of highest degree and of the constant. Meaning, we'll now start picking what is P of 1. We are looking for one that will give us a 0. If we get a 0, then we'll call it a fact. So P of 1 is 1 to the power 3 plus 2 by 1 squared minus 1, giving us 1 plus 2 minus 1, which is equal to 2. This is not 0. So 1 is not a fact. Negative 1, we will get negative 1 power 3 plus 2 negative 1 squared minus 1, giving us negative 1 plus 2 minus 1. This is 0. When you get a 0, we mean that x is equal to negative 1 is a factor of P of x. So we can use synthetic division. So we get negative 1, go back to px and get its coefficients 1, 2, 0 for x, negative 1 the constant. Drop a 1, multiply, get negative 1, add, you get 1, multiply, get negative 1, add, you get negative 1, multiply, get 1, add, you get a 0. The remainder is 0, confirming to us that what we have used is indeed a factor. So we can write px so far where we are. Px can be written as x plus 1 from this part here. So you return the negative 1 to its normal position, which is supposed to be x plus 1. Remember that the divisor is always equated to 0. So whenever you find x is equal to something, just know that it was equated to 0. So you can take back in that form and ignore the 0. Okay, so that you multiply this by the quotient, which is x squared plus x minus 1 you have factorized this. How do we know we are fully factorized? We are unable to factorize this guy. If it was possible, we could have factorized it. But look at how it is. Okay, we can't easily factorize it to have a normal thing, but we'll still improvise for us to be able to sketch. We'll use the quadratic formula for this piece. So because now our step two is to equate the factorized p of x to 0.
Sir.
Hello.
We're kind of asking for the previous board. You just need to see the last part.
All right. So you equate are you seeing the last part? Okay, so to equate and then solve for X-intercepts. So what it means is that you now get the px and equate it to 0 in its factorized form, which is x plus 1, x squared plus x minus 1 is equal to 0. That's how it is. No, it's x squared minus x plus 1. So x squared minus x, oh, my eyes can see. X squared plus x minus 1 is equal to 0. And then get x plus 1 is equal to 0, or x squared plus x minus 1 is equal to 0. The first one, x is equal to -1. The second one, x is equal to negative b plus or minus the root of b squared minus 4ac over 2a. Meaning -1 plus or minus 1 squared is just 1, minus 4a is 1, c is -1 over 2 by 1, giving us -1 plus or minus root of 1 plus 4 over 2. So that we have -1 plus root 5 over 2, or -1 minus root 5 over 2. What does it mean? It means that these are the x-intercepts. These are the values of x where the graph will cross or touch or cut the x-axis. Then step 3, find the y-intercept. By substituting x is equal to 0 in px. So what is p of 0? It will always be the constant. So what is the constant? -1. So the y-intercept is 0, -1. Then we can now sketch. So step 4. Step 4, sketch p of x. The sketch is just easy and nice. So you get the intercepts -1. The second one is -1 plus. Hello?
To even find the turning points.
No, so we'll find the turning points when we do calculus. For now, no.
Okay, thank you.
So for polynomials, before calculus, no turning point. But by the time you're getting in the exam, if they don't want you to find at any point, they'll just tell you to sketch indicating the intercepts. If they have combined it with calculus, they will tell you to sketch indicating the intercepts and the turning point. Then you know that you first do the normal thing of getting the x-intercepts, the y-intercept, and then add the calculus part where you get the turning points. So don't worry, I'll remind you when we get to calculus that this is the time now you get the intercept, the turning points for the polynomial. Then, of course, we are very sure that -1 minus -1 minus √5 over 2 is less than -1, because √5 is estimated to be 2 point something. So -1 minus 2 point something is -3 point something over 2, that is -1 point something. Then the other one is also estimated to be positive. Why? Because √5 is 2 point something. 2 point something minus 1 is 1 point something, positive. Over 2, it will still be positive. So now we know that there's a turning point between the left intercepts, another turning point after. So let's look at the y-intercept. It is 0, -1. So it's somewhere down here. Okay, so you look at the gap between. So since this gap here is bigger than the gap which is here, it means that our graph is going to turn in there. It's going to turn, so it will be like this. Wherever it's turning from, and go like that. So here, I've tried to estimate, I've checked the distances between -1 and 0, and the 0 and -1 plus √5 over 2. This distance here is smaller than this distance here, meaning that in this gap, that's where the graph is going to turn from. Now, if it's turning from this gap, it means that it will go beyond a -1.
Oh, so sir, there's no need of finding turning points.
No.
So
this is,
sir, the turning point, you just look at the side which is bigger from 0 to the first number on both sides. Then that's how you decide.
Yes.
All right, thank you. All right, thank you.
Feel free to ask questions. The graph, the question has,
Sir, I'm not clear on the turning point, making those.
On the turning?
Yes, on the turning. How, okay, what's making you to tell that it has to go up this way, up, down like that? Why didn't we start going down and then up? I don't know why you're doing that.
Okay, since the y-intercept is down here, it is 0, -1. The graph must pass through the y-intercept. So if we start from here, it will be hard for us to come to this, because it must pass through there. So the only way to pass through all these 3 points, including the y-intercept, is when it is in this direction. If we go this way, how do we come down to this? Because from there, it will mean we must go there for us to go there. So the y-intercept helps us to know the direction of the graph before we get to calculus. Calculus has its own way of telling us that your graph will be increasing here, decreasing there, and increasing there. But now we are before calculus. So we use the y-intercept to tell us that your graph must be oriented in this way for it to pass through all the 4 points.
Sir,
Mhm.
sir,
Yes.
why is -1 plus root of 5 over 2 to the right side? Why are supposed to be positives? Why is it like that?
Why is
Then all the numbers, all the intercepts have indicated them that they're negatives.
they're not negative.
Now why is it the other negative to the positive side? Why?
They're not negative. The only thing we have is we have one, a -1, which we are sure it is negative. -1 is negative, yes. -1 minus root 5 over 2 is negative, yes. But -1 plus root 5 over 2 is not negative. It just has a -1 in it.
So explain.
What is root 5?
Why?
Root 5 is bigger than what? Root 5 is bigger than root 4. But root 4 is 2. Meaning root 5 is 2 point something. Now 2 point something minus 1 is 1 point something. 1 point something over 2 is positive.
Okay, okay, sir. Thank you.
Good. The way I'm convincing you here is the way I want you to convince me in that test you wrote. Yeah. Okay. Another example. Okay, William. Linda, you're saying at the end of the lesson, and definition on example 1. Okay. At the end. So it doesn't yet ended. Okay. Next, we go to okay, so Vonga, I get back to the shape. How do you get the shape of the graph? You use the y-intercepts to give us the orientation. The key thing is that the graph must pass through all the points that you are determining here. All the intercepts, the x and y-intercept, the graph must pass through those intercepts. So if you have a y-intercept down here, it means that it must be oriented in this direction. If you miss the direction, if you start it this way, you get back there. How are you going to turn? How are you going to pass through this point and that one? Try it. Try to sketch in this direction. That's when you know that. But can't see. The intercept makes sense. So that's how you get to know that, okay, I cannot have any other orientation here when you are trying to do the actual thing. Let me answer this question now. On example 1. Example 1. Oh, you mean example 1 for synthetic? But look, we have partially answered this in this one here. So now I'll answer your question in another question. Another example will be the polynomial p of x is equal to 3x power 3 minus 3 x squared then plus 2x minus 2. That is a polynomial there. We want to sketch this function. So first step, we said you look for the factors and factorize this thing. The factors must be the factors of the highest degree coefficient and the constant. So now for 3, you can start with 1. Let's check 1. P of 1 is 3, 1 power 3 minus 3, 1 squared plus 2, 1 minus 2, giving us 3 minus 3 plus 2 minus 2, which is equal to 0. So 1, x is equal to 1 is a factor, meaning we can use it in a synthetic. I'm now explaining for Linda also. How do you do synthetic? You get the factor 1, go to the polynomial, and get the coefficients of the polynomial. If there is any missing power, you improvise by putting a 0 to represent that missing power. So you start with 3, the coefficient of x power 3, negative 3, the coefficient of x squared, positive 2, the coefficient of x, and negative 2, the constant. And then break it like that, then drop the first number, put it down. Multiply the outside number by the first number that you have taken down, you get 3. Add, we'll get 0. 1 by 0, we get 0. Add, we get 2. 1 by 2, we get 2. Add, we get 0. When 0 is the last number, then you know you are headed in the right direction. So now we are saying P of x has now become x minus 1. We take this one the other side, so it requires a negative. Multiplied by, get this 3, x. If the power is 3 here, we'll have 2 here. And then plus, supposed to be 0x, but we're writing 0. So you skip it and got the constant 2. Then equate this to 0 to find X-intercepts. So we'll have x minus 1, 3x squared plus 2 is equal to 0. So x minus 1 is 0. You substitute by 1 in trying to find a factor. So you could have, if 1 didn't work as a factor, could have gone for -1, for 2, for 3, until you find one that gives us a 0 as a result here, because only such numbers are called factors of that polynomial.
Sir.
Hello.
I'm lost there where you're multiplying and adding.
On the synthetic part.
Yes, sir.
So to do the whole synthetic, after you obtain the coefficients that you're collecting from the actual polynomial, and also having a factor to put outside here, your first thing is to drop this coefficient, you drop it down. Then you multiply 1 by this number here. What you get, you put down the second number, and then add these two. What you get, take down. Go back to the first number there, the one outside, multiply that number by this one to have a number that is going to the third position. Add these two, the number you get, multiply it by 1 again to get this number here. Add them until you get the last number. If your last number is 0, you can proceed. All right. Then also 3x squared plus 2 is equal to 0. So we have x is 1, or you can see that 3x squared is equal to -2 is not possible. How can 3 which is positive and the x which is squared be equal to a negative number? If you can't see why we say not possible, we get x squared is equal to -2/3. Square root, square root. The square root of a negative number is not a real number. So we only have one intercept. So let's get the y-intercept also. The y-intercept p of 0 is equal to a constant -2. So we have a point 0, -2. And then sketch. Don't even have to worry or solve. So we have gotten -2 and 1. So 1 is the turning point. And it must cross -2. So at least we are sure that this guy is going to, since we only have one intercept, and it is power 3. We don't know. It's possible that -2 also. No, it's not possible. So it may turn at 1 there or not. So let's check what we get. You just forget about it. When it refused to, which has refused to square root. When it refused to square root, you forget about it. Go for the one which has accepted to square root. Okay, so we now have these only two intercepts. So we try a number. Let's try. What happens at 1, at 2? We want to see whether it is above or it is below the 0. So if you try 2, you get 3 by 2 power 3 minus 3 by 4 when I square the 2 plus 2 by 2 minus 2. So 2 power 3 is 8 by 4, by 3 is 24 minus 12 plus 4 minus 2. So here we'll get 24 plus 24 minus 12, that is 12. 12 plus 4, 16. 16 minus 2, 14. So we have got 2,14. Somewhere there. So meaning that this guy, if you try to check on -1.
Sorry.
Hold on.
Why don't you square the 4? The -3 multiplied by 4.
It was a 2 initially, so we squared it.
Oh, okay. All right, thank you.
So we have 3 minus 1 power 3 minus 3 minus 1 squared plus 2 minus 1 minus 2. This will give us -3 plus 3, -3 minus 3. Since the -1 is squared, minus 3 minus 2 minus 2. That number is less than -2. So this means that this graph here, no, let's check also at positive half. There might be some misbehaving here. At positive half, P of half is equal to 3, 1/8 minus 3, 1/4 plus 2, 1/2 minus 2. So we get 3/8 minus 3/4 plus 1 minus 2, giving us 8 down, and then 3 minus 4 into 8 is 2. 2 by 3 we get 6, and then that is -1 into 8, so we get -8. So this will be -8 minus 3, that's -11. -11/8. This is -1 point something, which is less than 2. So that in this region, This curve is very, very difficult to sketch because it looks like it's a straight line, but it can't be a straight line. So it is a curve that's coming this way. Not a straight line though. Coming this way, goes there. Now when it reach here, it will hit as if it has made a turn going up. So it's just hard to graph because it looks like a straight line. But then it's okay, maybe I start from here. To hit here and start curving going down like that.
So are you sure this wouldn't be a straight line? Because if you look at the point.
No, it can't be a straight line because look at what 2 is giving us. And look at the gap between 0 and 1. So if it was to be a straight line, 0 is supposed to give us something like -4, so that it can go straight. I mean -14. So it will be some curve of some kind, but it's only one intercept on the X and then the Y. Sisters refuse to turn.
Sir,
Yes.
sir, now here when you're trying to see how this graph is going to turn, there's no need for you to find the other points, like the way you were doing last time. You substituted 2, you solved and you got 14. You're not going to put the 14 there.
So we did the number after 1, which is the intercept, a number before 1 between 0 and 1. So we could see if it was making this one a turning point. If it was making this guy a turn, because it's possible it can make this guy a turning point and turn somewhere to go there, but then it failed to be like that. Because see, the numbers you're getting when you try between 0 and 1 is something that is less than -2. I mean, that's bigger than -2, meaning we're going up. We also tried -1, it gave us a number lower than -2. That's why we said then it will be behaving in that form.
Sir, I don't understand.
So the trend that we are doing, if you had such a thing, you could try some numbers to see whether it must turn from down or after or before the y-axis. Is it? Okay, so